Okay, I hope it started again because last time I was just thinking it didn't start, but I was getting recorded. So let's just start now. So I'm gonna start with the book directly. I'll read it out and we'll study, right? Okay. So the first chapter is an overview of C++. In this, we'll start with what is C++. Let's just start from the basics. If we find something really basic, we can change it anytime. Okay. Uh, why does it feel like it's not getting recorded? Let me just check really fast. Mm, I'm so new to it. Why does it feel like? Sorry. Okay, I hope it started. Yeah, I think it's live right now, so it's fine. Okay. So let's get to it. We are going to start with the first chapter. I'm just looking at it so that if there is something really basic, I can skip that. It says, what is C++? In the early days of computing, programs were written in machine language, like we know, which consist of the primitive instructions that can be executed directly by the machine. Okay, that's fine. Machine language programs are difficult to understand, mostly because the structure of the machine language reflects the design of the hardware rather than the needs of programmers. Right, because when we are writing a machine language program, we are writing in zeros and ones, or maybe we are writing in the language which machine understands. But that's not a programmer friendly, so that's not for programmers. Then a group of programmers under the direction of IBM had an idea that profoundly changed the nature of computing. Would it be possible, they wondered, to write programs that resembled the mathematical formulas they were trying to compute and have the computer itself translate those formulas into machine language? Oh, that would be really cool, right? So they tried doing that. In 1955, they produced an initial version and they named it as the first example of higher level programming language. Um, yeah, it's called formula translation. That was the first thing they made. Okay. And there's a chart of multiple languages going on here. By the way, I'm not sharing my screen. I'm just sharing my face because I don't know. Let's just do it like this today. So then C++ represents the coming together of two branches in the evolution of programming languages. One language is called C, which is the ancestor, and the second language, yeah, there are like other languages also from which C++ is coming from, not just C. Now we are on the object oriented paradigm. So like most revolutions, whether political upheavals or the conceptual restructurings, um, this change has been driven by the emergence of the idea that challenges an existing orthodoxy. Initially, the two ideas compete. For a while, the old order maintains its dominance. Over time, however, the strength and popularity of the new idea grows until it begins to discipline the order idea in called a paradigm shift. Okay. So first of all, we were all doing the programming. Okay, even after making this first programming language, we started programming in the procedural language. That's called procedural paradigm. Because we were writing functions, we were not making classes. So, but then after that, we started doing object-oriented paradigm. That was like a shift of the paradigms. Um, then the idea of object oriented programming is not really all that new. The first programming language which was object oriented was Simula. Simula, that's really old, 1967. Okay. Then, for many years, Simula was the only language which was object oriented. And then despite many attractive features and a highly interactive user environment that simplifies the programming process, Smalltalk never achieved much commercial success. So there was something called Smalltalk 80, which is a book. Um, yeah, I think Smalltalk is like a little software we made to actually talk to each other, like a WhatsApp. Um, that's also in the object oriented programming. Although there were several parallel efforts to design an object oriented programming, okay, this is not important at all. Let's move ahead. Okay, let's move to the compilation process. When you write a program in C++, your first step is to create a file that contains the text of the program, which is your source file, as you know. Before you can run your program, you need to translate the source file into an executable form, which is called compiled code. And how do we do that? We do that using compiler. So when you translate a source file into an object file or a compiled file, you do it using compiler, and your object file will contain what? The machine level instructions. And you don't need to do it by your own. It will be done by compiler. That's what we were talking about. That can we make something like this so that software itself converts every program we write into machine language? And yes, we actually figured that out. So that's compiler. Then the other object files typically include predefined object files called libraries. So libraries are like a combination of functions and objects, or you can say classes inside it. The process of combining all the individual object files into an executable file is called linking. So when we are importing, including stuff into our file, let's say, it's still going on. Not sure. Okay, looks like it is still going on. So let's get to it because the electricity went out. Okay, so we'll do after that. So when we include some different files into our file to make it work completely, like we included vector or we include strings, that's called linking. Um, then, unfortunately, the specific details of the compilation process vary considerably from one machine to another. There is no way that a general textbook like this can tell you exactly what commands you should use to run a program on your system, because those commands are different from each system. For each system, you need to consult the documentation that comes with the compiler you're using on that machine. The good news, however, is that the C++ programs themselves will look the same. One of the principal advantages of programming in a higher level language like C++ is that doing so often allows you to ignore the particular characteristics of the hardware and create programs that will run on many different machines. Yeah, that's the thing. So you can just write the program and you can compile it in two different hardware options, maybe a Mac OS or a Windows or a Linux. So it's fine. You can compile it there. Then let's understand the structure of the C++ program. The best way to get a feeling for the C++ programming language is to look at a sample program such as the one shown below. So we have a program for the power table, which is we have n square, and we have 2 raised to the power n. So if the n is 0, the n square will be 0, and the 2 raised to the power n will be 1, because 2 raised to the power 0 is 1. Okay, that's a power table code, and it's stored in the power tab.cpp program. That's how we write it. Then inside it, they are also explaining what is a comment. So we already know a comment just consists of text enclosed between the markers, because in C++ how do we write the comments? We write it either using the double forward slash, that's just one liner, but if you want to write a multi-line comment, that's forward slash star, and then you write something. When you finish, you put star and the forward slash. That's simple. I don't even know why I'm doing this all, but let's just get into it. Let's just get a hang of it, then we'll move. Then okay, so initially in the file we are including some header files, like we are including genlib.h, iostream, iomanip, all of these. So hash include lines reflects the fact that the libraries comes from different sources. Okay, that makes sense. So whenever you do hash include, you are including a library which is coming from another source or another place. Source just means another file. So the first file we are including is the iostream, which is an input output stream library, or the stream manipulator library, which is iomanip. That's a stream manipulator library that is supplied along with C++. Oh, I got to know about a new thing today. Because there are two types of include statements we can write. We can either write hash include, and then those angular brackets we write, the less than and the greater than symbol. If we write something in that, we are including a public library which is available to everybody. But when we want to include a private library, then we use quotations instead of the angular brackets. That's for the private libraries. That's pretty cool. And what is a private library? Private library is the one which is specifically used for the program I am writing. It's not a general library present already. Maybe I have made it. It's user defined. So that's a library which is private, and to include that we can use the quotations. Okay, I like that. Then they are just showing me the sample program. They have some comments, they have some hash includes, another comments, some constant integer variables for the upper limit and the lower limit. Then they have a function definition, which is called a function prototype. They're just defining that this is integer function, it's going to return an integer, this is the name, these are the two integers we are going to pass as input, and then just a semicolon because it's a prototype. Then we have the int main. We have some couts inside it and a for loop which is going from the lower limit to the upper limit. Simple. Then we are actually making the function. But what I do usually is I do the hash includes and then I put the normal functions and then at the end I put the int main. But yeah, we can do this also. We can first put the prototype of the function at the top, then write the main function, and then we can write the function definition below. That's fine. They are also talking about some local variable declarations. So local variables are the ones which are inside a function. It's just function scoped, or some local variables are in the if else conditions also, those kind of things. Then yeah, that's basically it about the function, about the program they have. Now they are explaining some things that we are doing const int for two different variables. So yeah, we just need to put const in the front of it. That's called a type modifier. Type modifier const. So const is called a type modifier which you can put in the front of a data type and it will become constant, which we already know, but fine. Okay, other than that, they are also initializing a const double called pi. And they are saying giving symbolic names to constants have several important advantages in terms of programming style. So they are telling me that you should actually name pi as pi as uppercase, not lowercase. That's how you should write it because it has a meaning to it, which makes sense. Same thing about another constants they have initialized above, which is lower limit. That's also all uppercase. Same thing about the upper limit, it's all uppercase again. So all the constants should be initialized as uppercase. I got the point. Then we have function prototypes. What is a function? A function is a unit of code, performs a specific operation, and is identified by a name, which is simple. Yeah, every function has a name, so you call it by the name, and every function has a specific task. Now it is specifically saying, and it's also important in the what is that called? There are two types of programming, right? So it's very important that one function is only doing one task. It's explaining that. It says a function is a unit of code that performs one specific operation. So function should not do like a very, it should not be a very big function which is doing too many tasks. That's not a good thing. Okay. So they're again telling me about the function prototype, which we know that it's just a declaration of the function, but then below that we can actually define the function. Now they're talking about the main program. In the main program, yeah, they're just trying to explain the power tab.cpp they wrote, but they're explaining some things like cout, which we know. Cout is sending the information to the cout stream to display the output on the screen, which we know. Other than that, it's using those outward angular brackets. Then we have endl. Endl says that go to the next line, which we know. Then we have a for loop. A for loop is used to specify repetition, and they are also talking about set w, which is what? Set W that is inserted into the stream just before n indicates that the stream should format the next value in the field that is 3 characters wide. Oh, so set W means set the width of the character, which will come the next. Okay, that actually makes sense. Hmm. Set W. So let's say I want to print. Yeah, I want to actually try that because there's no output of this. Hmm. Let me just try it. So if I do int n equals 4 and then I do cout set w of n, no, set w3 of n, then I do end l, is the set w coming from somewhere? um, do I need to import something to use it? Probably yes. We need to import that thing which they did, iso manip. Let's try including that. Okay, let's just run it. The editor which I'm using, it's giving me error. I can try using it for a string instead of a number. Still gives error. So I'm not sure how to use this. Let me just search for it then. Set W in C++. Okay. Yeah, it's coming from the iso manip because I was thinking that it is changing the, because iso manip is to manipulate the input output, and it's actually manipulating it because whatever we are outputting it, we are actually trying to set a width for that output. But how do we use it? I was also trying to use it in the same way, but I think it's about the editor. It was not working, but it actually gave me the answer and the examples. It's trying to do the set W8 on 10, and I see that yeah, it's putting some spaces in the front. It's not putting zeros, but the spaces in the front and starting the actual number from the end so that it fulfills that width. Okay, that was something new, so that's good. Let's move ahead. The last statement, return 0, indicates that the function result is 0. The return value from the main function is used to communicate the success or failure of the entire program. By convention, a result 0 indicates success. So that's just a default value of main return from the main, so that it just indicates it's a success. But you can't say that 0 usually means success. It's just for the main function. Okay. Then we are also making a result variable which is an integer. And we are using assignment statement. We are using multiply equals, which we already know that it's used to multiply the result and put it back into the result variable. Now we are on another part of the first chapter, which is 1.3, variables, values and types. So the first thing is variables. Variables, okay, let's see what is the definition written here, because I know The definitions are not correct everywhere about the variable. Data values in a program are usually stored in variables, which is not really correct. Hmm. In C++, if you want to use a variable to hold some information, you must declare that variable before you use it. Yeah, that's fine. Everywhere you need to do the declaration of whatever you're using because you're doing C++. Declaring a variable establishes the following properties. Okay, this is really white. Can I make it black by any chance? It's it's not friendly for my eyes. I don't think I can. If I download it as a book, then probably I can. We'll try. I have a lot of things opened. It's just getting really slow. Let me close these. I don't think I need all of this also. I'm gonna close this. Okay, I have OBS and this. I don't need this also. I'm gonna close that. Oh, I have too many things open. I close this also. Okay, now it's good. So I've downloaded it. Let me try opening it into some Mac software. I know that there's a software for the books. Let me get it from the launchpad. Yeah, it's books, but I'm not sure if oh yeah, PDFs. Your library will automatically be added in the collection. How do I? Hmm. Okay, I think I have it here. Can I open it? Oh, no, I can't. Hmm. Should it? I just- Yeah, it's not in the format of a book, so I can't read it in the books of Mac. Okay, that's fine. So, yeah, so data values in the program are usually stored in variables. In C++, if you want to use a variable to hold some information, you must declare that variable before you use it. Okay, that's fine. Name. Every variable has a name which is formed according to the rules described in the section entitled Naming Convention later in the chapter. Okay, there's a type, which is the data type. There's a lifetime of the variable. Depending on how they are declared, some variables persist throughout the entire program, while others are created and destroyed dynamically as the program moves through various levels of function calls. Yeah, that's true actually, because If there's a variable which is globally named, it will it will be uh, it will be there throughout the whole program. But if there's a variable which is declared in a function, once you are in a function call, then you will have the access of that. But once you're out of that, it will get destroyed by itself. So there is something called lifetime of a variable, which is a good thing. The lifetime depends on the scope actually. So scope of the variable is to control what part of the programs have access to the variable. It's so hard these days. Okay, like they are showing me. Okay, we got another word called initializer. Initializer is an initial value specified as part of a declaration. It's called initializer. Okay, if you're just saying int result equals 0, then it's an initializer. That's the initial value. Now we got to the naming conventions. There are some. The name must start with a letter or the underscore character. Good. All the characters in the name must be letters, digits, or underscores. No spaces, no other special characters are allowed. The name must not be the one of the reserved keywords listed in the table. Uppercase and lowercase letters are fine, and they are considered to be different. So it's case sensitive. Then oh, this is a new thing. So identifiers can be of any length, but make sure you make, okay, identifiers is the same thing as variable. So identifiers can be of any length, but you need to make the identifiers so that if you're making two identifiers and they have almost a similar name, but after a while you changed some characters, but it's just the same if you start from the beginning. So make sure that in the first 31 characters itself you do some change so that they both are different, because the compiler of the C++ just checks the first 31 characters to know that these two variables are different or the same. It doesn't check anything after that. It doesn't check anything after the 31 characters. It's very important. That's something new. Okay. Then we got to the C++ reserved keywords. We have ASM, auto, bool, break, it. Okay, I'm not gonna pronounce. Should I? Okay. Break, case, catch, char, class, const cast, continue, default, delete, do, double, dynamic cast, else, enum, explicit, extern, false, float, for, friend. Okay, I remember there is a friend thing in C++. It's good that we are going to learn that. There's a goto, I remember that. Goto and friend, I think these are from C probably. There's inline, int, long, mutable, namespace, new, operator. Yeah, operator. I remember that operator is used to actually do operator overloading. Yeah. Then private, protected, public, register, reinterpret cast. Wow. Return, short, sign, size of, static cast, struct, switch, template, this, throw, true, try, type def, type ID, type name, union, unsigned, using, virtual. Using is also a keyword. Virtual is also a keyword. I think I know about that. There is a concept. It's very, very blurry, so I don't remember. Volatile, wchar, t, while. It's very nice that we are going to do all of this together. Local and global variables. Okay, have. Okay, I need to check again if I'm still live because I'm new to this. If I'm not live, it's not a waste of time, but I want to be accountable. That's it. Looks like I'm still live. Hmm. It's not a waste. Okay. So we are on the local and global variables. Most variables are declared with the body of the function. Such variables are called local variables. So basically, the functions which are declared inside of, a variable which are declared inside a function definition, that's called a local variable. Because once that function is done, you're out of the function, your local variable will also be destroyed. The lifetime of a local variable is the time during which the function is active. When the function is called, space for each local variable is allocated for the duration of the function call. When the function returns, all of its local variables disappear. Yeah, that's an important thing. If a variable declaration appears outside any function definition, so it's not inside any function, it's out of everything, then it's called a global variable. And the scope of a global variable is the remainder of the file. The remainder of the file means the end of the file in which it is declared. That's good. Hmm. So its lifetime continues throughout the entire execution of a program. Global variables are therefore able to store values that persist across functions. Hmm. Although they have important applications, global variables can easily be overused because global variables can be manipulated by many different functions. It is harder to keep those functions from interfering with each other. Hmm. That's true. So if you have a global variable, you can try changing that global variable using multiple functions. And if you try changing using multiple functions, there can be they can interfere with each other. That's why global variables are not used that much. Let me get some water. Okay, so we are at the concept of a data type. One of the reasons C++ requires all variables to be declared is that doing so constrains their contents to values of a particular data type. Hmm. So we need to declare everything as a specific data type in C++. so that the content of all of the variables which are from the same data type can lie at the same place. From a formal perspective, a data type is defined by two properties: a domain, which is a set of the values that belong to that type, and a set of operations. Okay, so a data type has two things: a domain, that means what all kind of values, what all set of values belongs to that data type, and a set of operations, so whatever behavior that set of values can perform with each other. For example, the domain of the type int includes all the integer, all the negative integers, -2, -1, zeros, and the positive integers, up to the limits established by the hardware of the machine. The set of the operations applicable to the value of type int includes, for example, the standard arithmetic operations like addition, multiplication. Other types have a different domain and a set of operations. So, till now, if I have to write something, what I did, it will just be like 2 lines, not even that much. Okay, I think I'll write it at the end because then I'll remember way less than what I remember right now. Right now, I know that we did set W, that was new. We also did that what a variable contains, like what a data type has. It has a domain and a set of operations. We also got to know about what we did something. If I just go through it, I will remember. But yeah, let's not go through it again. Okay. As you will learn in chapter 2, much of the power of the high level languages like C++ comes from the fact that you can define new data types from existing ones. To get that process started, C++ includes several fundamental types that are defined as a part of the language, such as we have a string data type, which is standard. These types, which act as the building blocks for the type system as a whole, are called atomic types. So some standard types, data types, are called atomic types. These predefined types are grouped into 4 categories: integer, floating point, text, and boolean. Integer is just int. Floating point includes float and double both. Text contains char and string. Boolean is just bool. Integer types. So we are on the integer type. In the integer, we know that we can store whole number, and then we have different types of integers, and each of them have a specific, a limited capacity to them. Like we have a short int, we have long int. So there are 3 different types of integers. There is a range of size which they have. Like a normal int can maximum store a number which is 32767. That's the maximum it can store. Oh, yeah, that's the maximum value. For the long, the maximum value is, okay, it's not really useful to like just remember these values. You can say int goes till maximum 2 raised to the power 15 minus 1, and the long int goes till 2 raised to the power 31 minus 1. And the short, what about short? For example, okay, the internal size of an integer cannot decrease as you move from short to int to long. For example, decide to make short and int the same size but could not make int smaller than short. Okay, so they didn't really mention what's the size of a short. The ability to move a program between different machines is called portability, which is important consideration in the design of a programming language. In C++, each of the integer types, int, long, short, may be preceded by the keyword unsigned. Adding unsigned creates a new data type in which only non-negative values are allowed. Signed actually means that it has a sign bit. Sign bit means it's a negative, because if you have a sign bit, it's a negative number. But if your integer is unsigned, that means it just contains positive values or non-negative values, you can say, including 0. Because unsigned variables do not need to represent negative values, declaring a variable to be one of the unsigned types allows it to hold twice as many positive values. For example, if the maximum value of type int is this much, the maximum value of type unsigned int will be this much. Oh, so it can store almost double. Not almost double, it's just the double. Yeah, so it can store the double. Nice. If the maximum value of int is 32767, then the unsigned int's maximum value is 65535. Which is nice. Oh, I actually understand, because if we talk about the bits, the first bit, the very first bit, is actually storing negative, a bit to say that it's a negative number. But if we don't say it's a negative number, that bit can also be used to make the integer, and it will be twice as big because it's the front bit, and that will be really high power of 2. Kind of makes sense. An integer constant, wait, so some variables intended to store size are declared as unsigned because the size will always be non-negative. Okay, so if you want to store sizes in a variable, you can make it unsigned, because size can never be negative. It will always be non-negative. That makes sense. An integer constant is ordinarily written as a string of digits representing a number in base 10. If the number begins with the digit 0, however, the compiler interprets the value as an octal base 8 integer. Thus, the constant 040 is taken to be an octal and represents the decimal number 32. If you prefix a numeric constant with the character OX, the compiler interprets it as a hexadecimal. You know that. So, a normal number is a decimal. If you have 0x, that's hexadecimal. If you have 0O, oh, in this case, if a number just starts with 0, then it's octal. If it starts with 0x, then it's hexadecimal. If it starts with 0L, it's a long. And if it starts with U as a suffix, no, it doesn't start with that basically. It ends with that.
केक तो काट दूंगी मैंने खाया नहीं था मेरे बिल्कुल बहुत नहीं खाया
बाद में. Floating point types. Numbers that include a decimal fraction are called floating point numbers, which are used to approximate real numbers in mathematics. As with integers, C++ defines 3 different floating point types: float, double, and long double. Although ANSI C++ does not specify the exact representation of these types, the way to think about the difference is that types that appear later in the list allows number to be represented with the greater precision but require more memory space. Unless you're doing exacting scientific calculation, the differences between those types will not matter a great deal. In keeping With a common convention among C++ programmers, this text uses the type double as its standard floating point type. Floating point constants in C++ are written with a decimal point. Thus, if 2.0 appears in a program, the number is represented internally as a floating point value. If the programmer had written 2, this value would be an integer. Floating point values can also be written in a special programmer style of scientific notation in which the value is represented as a floating point number multiplied by an integer power of 10. Okay, that's e is 10 raised to the power, so 2.9979 e raised to the 10 raised to the power 8. Text types. We are done with the integer types and the floating types. In the integer types, we learned that is an int, long, short. They have different sizes. Then we have unsigned. If we make a integer unsigned, that means it can store the maximum value up to twice of the normal storage capacity. In the integer, if we just write a number normally, that's base 10, which is a decimal number. Otherwise, if we write a 0 in front of it, that's an octal. And if we put 0x in front of it, that's a hexadecimal. If we put L in front of it, not in front of it, if we put L at the end of it, it's long. If we put U at the end of it, it's unsigned. Then we did floating point numbers. We have float, double, long, double. It just says that the more you go to the right side of it, float, double, and long double, the more precision you will have, and it will take more memory space. We can also show it as a scientific notation. Then we have text types. So in early days, computers were designed to work only with the numeric data and were sometimes called number crunchers as a result. Modern computers, however, work less with numeric data than they do with the text data. That is, any information composed of individual characters that appears on the keyboard and the screen. Further, the ability of the modern computers to process text data has led to the development of word processing systems, online reference libraries, electronic mail, and a wide variety of other useful applications. So, the modern computers have a capability to okay, let's get back to the work. So, the most primitive elements of text data are individual characters and that are stored in a predefined data type called char. The domain of type char is the set of symbols that can be displayed on screen or typed on the keyboard. The letters, the digits, the punctuation marks, space bar is also a character, return key is itself a character, so forth. Internally, these values are represented inside the computer by assigning each character a numeric code. In most implementations of C++, the coding system used to represent characters is called ASCII, which stand for the American Standard Code for Information Interchange. The numeric values of the characters in the ASCII set are shown in the table 1.2. Although it is not important to know that the characters are represented internally using a numeric code, it is not generally useful to know that what numeric value corresponds to what particular character. When you type the letter A, the hardware logic built into the keyboard automatically translates that character into the ASCII code 65, which is then sent to the computer. Similarly, when the computer sends the ASCII code 65 to the screen, the letter A appears because computer will send the answer in the numeric form also, right? but we will see it in the character or the text format. So it will again do the conversion for us. You can write a character constant in C++ by enclosing the character in single quotes. So you need to make sure that you're making a single quotes for character. Thus, the constant A represents the internal code of the uppercase letter A. In addition of the standard characters, C++ allows you to write special characters in a two character from beginning with a backward slash. These two character combinations are called escape sequences. So escape sequences are a two character combination and you can put it in the single quotes and you can use it as a char, like backslash n is a very commonly used one. It's for the enter, like next line you can say. Backslash t is for the tab and double backslash is the actual backslash character, because if you just put single backslash it's not going to show you anything. If you want to actually show backslash, then you need to put double backslash. And that's it. Now let's move to characters are most useful when they are collected together into sequential units. In programming, a sequence of characters is called a string. String make it possible to display informational messages on the screen. You have already seen strings in the sample program powertab.cpp. It is important, however, to recognize that the strings are data and that they can be manipulated and stored in much the same way that the numbers can. The standard C++ library defines a string type and operations that manipulate strings. The details of type strings are not important at this point. Strings are considered in more detail in chapter 3. In this chapter, strings are treated as atomic values and used exclusively to specify text that is displayed directly on the display screen. You write string constants in C++ by enclosing the characters into double quotes. C++ supports the same escape sequences for strings as for the characters. If two or more strings constant appear consecutively in a program, the compiler concatenates them together. The most important implication of this rule is that you can break a long string over several lines so that it doesn't end up running past the right margin of your program. If two or more strings constant appear consecutively in the program, the compiler concatenates them together. The most important implication of this rule is that you can break a long string over several lines so that it doesn't end up running past the okay. Yeah, I've seen this a lot, that if you have a string which is going in like different lines, you can actually break that string by using the backslash, and you can go to the next line and keep on continuing the same string, which is cool. Boolean type. In the programs you write, it is often necessary to test a particular condition that affects the subsequent behavior of your code, and whenever you are checking a condition, you are always using Boolean data, that's true or false, and you write it in lowercase. In C++, the Boolean type is called bool, and it shows true and false. Okay, we'll move to the input output, simple input output. So we have hmm, so input and output. Before taking an input, you can actually do a cout to give the prompt to the user that this is what we are expecting it to enter. So it enters the same thing, and then when we output, then also we show some kind of text to show the user that I'm printing this. Okay. Okay, I need to do one thing. Let me apply if there is a job, and if not, then it's fine. Jobs. I need to keep on checking, having an eye on it these days. Okay, no jobs in Python, no jobs in computer science. What about the data science? Do we? Not really. What about the databases? No. Do we have in Java then? Oh, we have something, but that's not what I know because it's Java plus Spring plus Spring Boot. Okay, I don't know that. That's fine. Then we will. Okay, we'll do. Actually, I can. Okay, I've messaged one person. Let me also see if there is something in JavaScript. And I'll check web development. Okay, not in JavaScript. About the web development. Could you please let me know if you build mobile application is teach languages like to build an app for students how they can learn and engage. Okay. No, we don't really. No, I don't really know how to make mobile applications. So that's fine. We are gonna learn that soon. Okay, let's get back to work. Stream manipulators can be used to control the formatting of the output. A manipulator is inserted into the stream ahead of the values it affects. The manipulator does not print anything to the stream but changes the state of the stream such that subsequent insertions will use the requested formatting. A few of the more common stream manipulators are shown in the table on. I also need to check one more thing. 1 second. Top, down. Okay. Nothing tomorrow. Wow. It's insane. Okay, I'm good now. We'll move again. So it's just talking about that we have string manipulators or input output manipulators, which is called stream manipulators, and it's included in the IO manip library. Then some common output stream manipulators are set W, which set the field width to n characters if the value to be formatted is too short to fill the entire field width. Extra space is added. This stream property is transient, it affects only the next value inserted into the stream. Then, oh, okay, so we need to put the set W first, and then we need to put the value after that, which we want to set the width for. Then we have another common manipulators called set precision, and it sets the precision to n places. As you know, precision means how many digits do you want to display on the right side of the decimal point. So this property is persistent. Once set, it applies to all the subsequent values inserted into the stream. So actually you can use it above, and then you can apply it to all of them. Okay, then we have left sets the justification for values that are smaller than their field width. Left justification will cause the values to line up along the left, padding with the spaces on the right. This property is persistent, same as the left but to the right, padding with the spaces on the left. Okay, that's fine. Then we have expressions. We write it to perform calculations. You need to write an expression that specifies the necessary operations in a form similar to that used for expression in mathematics. Okay, so like we can easily convert any expression into a C++ expression. Minus b plus sqrt, that's the function. B multiply b minus b. Okay, this is actually looking simple. Okay, there are few differences in form. Multiplication is represented explicitly by a multiplication sign. Division is represented as /. The square root function is spelled out, but the expression nonetheless captures the intent of mathematical counterpart in a way that is quite readable, particularly if you have written programs in any modern programming language. In C++, an expression is composed of terms and operators. Terms such as variables a, b, c, and the constants 2 and 4, those are the terms, and the operators are like plus, minus, in which are used to do the actual operation between those terms. Then we have precedence and associativity, because it depends which thing you are going to solve first in an operation, and that depends on the precision and also the associativity rule. So precedence, we have a precedence table right here. Associativity just means that if some things have same precision, then how do you associate it? So you start from the left side of that whole line of the precision operators, or of the same precision operators, or you start from the right to the left. So like all the parentheses, no, not all the parentheses. If I talk about the simple things, then plus and minus are having the same precedence, but we started from the left to right. We solved the plus first and then the minus. Same thing with the multiply, divide, and the modulo. They all of them have the same precedence, but we started from the left. Associativity again. We solve the multiplication first, then division, and then. I mean, that's not the thing. We just start from the left to the right. If they all are present in an expression, then we just start solving the expression from left to right, or right to left, based on how the associativity is. So you can just remember this table for now. There are two types of operators. One is binary operator, which needs two operands. Otherwise, there is a unary operator, which just needs a single operand. The precedence of unary and binary versions of an operator are different and are listed separately in the precedence table. If two operators have the same precedence, they are applied in the order specified by their associativity, like I just said. So most operators in C++ are left associative, which means the leftmost operator is executed first. Very few operators, primarily the assignment operators are like plus, equals, minus, equals, those kind of, which are not even present here. So those operators are right associative mainly, which mean that they are evaluated from right to left in the whole expression. Okay, this is fine. Make sure you put parentheses at all the places which you want to execute first, and then you want to do something with them later. Mixing types in an expression. You can write an expression that includes values of different numeric types. If C++ encounters an operator whose operands are of different numeric types, the compiler automatically converts the operands to a common type by determining which of the two operands types appears closest to the top in the table 1.5. Oh, the result of applying the operation is always that of the arguments after any conversions are applied. This convention ensures that the result of the computation is as precise as possible. As an example, suppose that n is declared as an int and x is declared as a double. The expression n plus 1 is evaluated using integer arithmetic and produces as a result of type int. So double has more value basically. So if you have a double and integer adding together, you are going to make the answer as double. You will convert the integer into the floating point and then add them together using double precision floating point arithmetic, which results in the value of type double, which is fine. Integer division and the remainder operator. You know about the division normally. So the fact that applying an operator to two integer operands generates an integer result leads to an interesting situation with respect to the division operator. If you write an expression like 9 divided by 4 with a forward slash, C++ rules specify that the result of this operation must be an integer because both the operands are of type int. Oh, that sounds pretty cool because how do we know that the answer is going to be int? Because they both are int. Okay, but if one of them or both of them, so basically if at least one of them is float, then the answer is also going to be float. After that, yeah, it's just saying that if both the values are of the type int, then we will discard the decimal fraction. It's called truncation. So it will itself discard the decimal fraction from it. That's truncation. There is an additional arithmetic operator that computes a remainder, which is indicated in C++ by the percent sign. The percent operator returns the remainder when the first operand is divided by the second and requires that both operands be of one of the integer types. For example, the value 9 modulo 4 is going to give you 1 since 4 goes into 9 twice with 1 left over. Okay, we know all of this. The division and the modulo operators turn out to be extremely useful in a wide variety of programming applications like the Modulo operator, for example, is used to test whether one number is divisible by another. For example, to determine whether an integer n is divisible by 3, you just check whether the result of the expression n modulo 3 is 0. It is, however, important to use caution if either or both of the operands to division or modulo might be negative because the results may differ from machine to machine. On most machines, division truncates its result towards 0. Oh, but this behavior is not actually guaranteed by ANSI standard. In general, it is good programming practice to avoid using these operations with negative values. So you should actually avoid doing these operations, you like the division and the modulo, using the negative values. That's not a common thing to do. Typecast. In C++, you can specify explicit conversion by using what is called typecast, a unary operator that consists of the desired type followed by the value you wish to convert in parentheses. Still don't know what she sent it. No idea. Okay, that's fine. In C++, you can specify explicit conversion by using which is called typecast, a unary operator that consists of the desired type followed by the value you wish to convert in the parentheses. For example, if num and den were declared as integers, you would compute the floating point quotient by writing double. बस चल रही double of num den. The first step in evaluating the expression is to convert the num to a double, after which the division is performed using floating point arithmetic as described in the section on mixing types in an expression earlier in this chapter. Int of 1.999 is going to be 1 because it just takes the part before the decimal point. Okay, we are at the assignment operator, but let me just close it for now and stop streaming because I need to go somewhere. I'll see you when I come back.